This is section 3.2 of MA 104, numbers 33 through 45, odd. That should say odd. We're asked to find a linear function f that satisfies the given conditions. And then we're given two different equations in functional notation. If you recall, f of x is the same as y, so when I have f of negative 2 equals 2, the negative 2 takes the place of the x, and the 2 represents the y. So this is actually the point negative 2, 2. Similarly, this is the point 0, 10. Because I have 2 points, to find a linear function, I first need to find the slope. To find the slope, I would subtract the y-coordinates for the numerator, which would be 2 minus 10. The 2 comes from the y-coordinate of this point, the 10 comes from the y-coordinate of this point. And then in the denominator, I'll subtract the x's, negative 2 minus 0. That tells me that the slope is negative 8 over negative 2, which is positive 4. So the slope of this function is 4. If I recognize that the point 0, 10 is actually the y-intercept, then I don't need to do any calculations for the y-intercept. I can use the slope and the y-intercept to know that the equation is f of x equals 4x plus 10. This follows the slope-intercept form of y equals mx plus b to represent a linear equation. But rather than writing it that way, we're writing it in functional notation, where the f of x takes the place of the y. This is the same type of problem. The negative 2 represents the domain value of x, and the 7 represents the corresponding range value of y. So f of negative 2 equals 7 tells us that the point negative 2, 7 is a point of our linear function. Similarly, for negative 2 is a point of our function. To find the slope, I will subtract the y-coordinates, so that is 7 minus a negative 2. I have the 7, which is the y-coordinate of this point, the negative 2, which is the y-coordinate of this point. And then in the denominator, I'll subtract my x's, which gives me negative 2 minus 4. If I simplify, I have positive 9 over negative 6, which simplifies to negative 3 halves. My slope is negative 3 halves. I need the y-intercept to be able to write that function. So I'll use the idea that slope-intercept form is y equals mx plus b. I have the slope, I have the m. I just calculated that was negative 3 halves. I also have x's and y's. I can pick one of the points to find the x and the y. Substituting, and again, I'll just use this point, and I'll plug the 4 in for x and the negative 2 in for y. So that gives me negative 2 equals my slope of negative 3 halves times x, so that's times 4, plus b. This tells me that negative 2 equals negative 6 plus b. I can add the 6 to both sides and find that 4 equals b. So now I know that my slope is negative 3 halves, my y-intercept is 4. If I put those together, instead of writing y, I'll write f of x. I have f of x equals negative 3 halves x plus 4. For this problem, I am asked to find the domain, the x-intercept, and the y-intercept. To find the domain, I have to consider that the domain is all real numbers, and then remove any numbers which put zeros in the denominator of a fraction or negatives under a radical. I don't have any radicals, so I don't have to worry about that. But I do have this variable in the denominator, which is 2x plus 4 is my denominator. So to find out what value I need to remove from the domain, I'll take the 2x plus 4 and set it equal to 0. Solving by subtracting the 4 from both sides gives me that 2x equals negative 4. Divide both sides by 2, and I find that x equals negative 2. This tells me that plugging a negative 2 in for x will put a 0 in the denominator. So I have to remove that from the domain. The domain then is the set of all x such that x is not equal to negative 2. To find the x-intercept is the point where y is 0. I don't have a y in this function, but I do have an f of x, so let's do this way. So to find the x-intercept, I would replace the f of x with 0 equals 3x minus 12 over 2x plus 4. To clear the fraction, I would multiply both sides by 2x plus 4, which still gives me 0 on the left, equals 3x minus 12. Solving gives me 12 equals 3x, which tells me that 4 equals x. So my x-intercept is the point 4, 0. In other words, when y was 0, x was 4. Finally, I need to find the y-intercept. The y-intercept is the point where x is 0. So what I need to do is calculate f of 0, which involves replacing every term that has an x in it with a 0. So I have 3 times 0 minus 12 over 2 times 0 plus 4, which gives me 0 minus 12 over 0 plus 4, which simplifies to negative 3. So my y-intercept is the point 0, negative 3. To find the domain, x-intercept and y-intercept in this problem, to find the domain, I need to remove the values of x that make the denominator equal to 0. To find out what that is, I'll take that denominator of 4x plus 5, set it equal to 0. If I solve that equation, I know I have to throw that number out because that's the value of x that will put a 0 in the denominator. Divide both sides by 4, and I find that x is 5/4. Plugging a 5/4 in for x will make the denominator equal to 0. So the domain is just the set of all x such that x is not equal to 5/4. I have to throw that 5/4 out. To find the x-intercept, I would set y equal to 0, which in this case is represented by f of x. So I have 0 equals 3x minus 2 over 4x minus 5. Multiplying both sides by 4x minus 5 gives me 0 equals 3x minus 2. I would add my 2 to both sides and get 2 equals 3x. Dividing both sides by 3 tells me that x is 2/3. So my x-intercept is the point 2/3, 0. And finally, to find my y-intercept, the y-intercept is the point where the x values are 0. So this involves calculating f of 0, which is 3 times 0 minus 2 over 4 times 0 minus 5, which is negative 2 over negative 5, which is positive 2/5. So my y-intercept is 0, 2/5. For this one, finding the domain still means setting the denominator equal to 0 and then removing any of those values. So I would take the x minus 2 quantity squared and set it equal to 0. To clear the squared, I would take the square root of both sides. So I can think about this as taking the square root of this side and plus or minus the square root of 0. So this leaves me with the quantity x minus 2 equals the square root of 0 is still just 0. Add my 2 to both sides and find that x equals 2. So the value 2 would put a 0 in the denominator of the fraction, which means that my domain is the set of all x such that x is not equal to 2. Finding the x-intercepts means setting y equal to 0. In this case, that would mean setting f of x equal to 0 equals 4x over that quantity, x minus 2 squared. Multiplying both sides to clear the denominator leaves me with 0 equals 4x. Divide both sides by 4, and I get that x equals 0. So my x-intercept is 0, 0. To find the y-intercept, I find f of 0 because I plug the 0 in for x. That gives me 4 times 0 over the quantity 0 minus 2 squared, which just equals 0. So my y-intercept is also the point 0, 0. Finding the domain for this function means taking the x squared minus 9, setting that equal to 0. If I add my 9 to both sides, I am left with x squared equals 9. I can take the square root of both sides, so I would have the square root of x squared and plus or minus the square root of 9. So I end up with x equals plus or minus the square root of 9 is 3. So in this case, there's two values that I have to exclude from the domain. My domain would be the set of all x such that x is not equal to plus or minus 3. Finding the x-intercept, again, means setting f of x equal to 0 equals x squared minus 16 over x squared minus 9, multiplying both sides by that denominator to get 0 equals x squared minus 16. I can add the 16 to both sides and get 16 equals x squared. Taking the square root of both sides gives me plus or minus 4 equals x. There's actually two x-intercepts in this case, so this graph crosses the x-axis at 4, 0 and negative 4, 0. Finally, for the y-intercept, we will find f of 0, which will give us 0 squared minus 16 over 0 squared minus 9, which leaves me with negative 16 over negative 9. A negative over negative is a positive, so my y-intercept is positive 16/9, which translates to the point 0, 16/9. Finding the domain of this function requires me to take the x squared minus 25, set it equal to 0. I can add the 25 to both sides, which leaves me with x squared equals 25. Taking the square root of both sides gives me x equals plus or minus 5. Again, two values that have to be excluded, two values that could put a 0 in the denominator. So my domain is the set of all x such that x is not equal to plus or minus 5. For the x-intercept, we'll plug 0 in for f of x equals x squared plus 7 over x squared minus 25. The fraction clears and I am left with 0 equals x squared plus 7. Subtract the 7 from both sides and I'm left with negative 7 equals x squared. If I take the square root of both sides of this equation, I end up with x equaling plus or minus I square roots of 7. In other words, there's no real number that I can square to get the square root of 7. This means that there are no x-intercepts. In other words, that graph is not going to cross the x-axis at all. I can't have negative numbers on a real coordinate system, so I know that I have no real x-intercepts. For my y-intercept, it still involves finding f of 0. That gives me 0 squared plus 7 over 0 squared minus 25. So that's 7 over negative 25. So my y-intercept would be the point 0, comma, negative 7/25.